Hello, it's Frank here from datadriven.tv, the podcast where we talk about the emerging fields of data science, machine learning, and artificial intelligence. And today I'm here to talk to you about predictive models. And if you're watching the video, you probably see that I'm outside and that it is snowing. On this first day of spring here in the Northern Hemisphere, we have a snowstorm or a nor'easter pounding the East Coast, including where I live in the Washington, D.C. area. Now we're supposed to get 4 to 6 inches of snow or something like that. But one of the things what does it have to do with data science, right? So one of the worlds where predictive statistics or predictive models play into our lives on a daily basis is weather prediction. And one of the problems with weather prediction is getting it right. Now, I would posit that um, the weather models are probably more right than they're wrong, except for things like big storms, because the news likes to hype the big storms, so you tune in and listen to them. And this was one of those cases where I just didn't believe that it would actually snow today, because, well, one, it's after St. Patrick's Day, and that's extremely rare. Snow in March, just so you know, for context, snow in March in DC is extremely rare, as is snow, particularly in the latter half of March, which obviously this being March 20th we're in the final third of March, and it's rare, and it doesn't happen very often. So that's why. So I had my own cognitive bias in the predictive model inside my head that it would not snow. But in fact, it has, and probably school will be closed tomorrow. But the point here is we all have cognitive biases. Whether we think the weather reports are accurate or not may or may not be true. I think we tend to remember when the weather reports are wrong, because obviously if it's raining and you didn't bring the umbrella because they said it would be sunny, you remember that. So I think cognitive bias plays a big role in at least analyzing the performance of predictive models, especially in terms of where you can't do it objectively with statistics. So for plain English, basically, that's why there's something called the confusion matrix, where you figure out type 1 errors, type 2 errors, aka false positives and false negatives, and how many times that a prediction came true, that it said it would be true, and how many times it was false that it didn't. So this is why you want to have hard numbers behind evaluating your models, because otherwise you fall into cognitive bias. So with that, I'm going to get outside of the snow. And one of the more interesting things about snow this late in the season is it's not that cold out. So you actually could uncomfortably go out in just a t-shirt, particularly if you like cold weather. But so with that, I'm gonna cook up something hot and warm and maybe have a hot cup of coffee. You have a great day.